Okay, so now let's go ahead and implement our generate permutations function. Now, if you look at it, we will get an array, and luckily in this we are taking a integer array, not the string like we discussed in the algorithm, so that we get the best of both the worlds. Let me change this array to this. Ideally, they both are the same notations, so they both mean the same. There's no difference. Okay, so what we need to do is we need to create the permutations of this. Now the challenge was at every step, like we need to fill positions one by one. This is what we discussed, and to fill a position we need to know what are our choices. These are the two things we said that we need to remember the choices, and when we run out of choices we print our permutations. That was the last step of our animation, and we print our permutation and we backtrack, right? So, and if we have more choices available, like we here we said we have, if we have more choices to fill the position, we need to know our choices. Follow each choice one by one and keep moving forward till we get a permutation. So this is kind of in words the algorithm that we discussed. Now we have to be careful about how do we track the choices, or how do we make sure that the remaining choices that we have, we keep track of them. So one thing is, since we are filling the positions one by one, first we'll fill the 0th position, then we'll fill the first position, then we'll fill the second position. So we need to know which position we are filling currently. And as we taught you the trick earlier, that whenever you need to have a track of which positions we need to fill, we always go ahead with the helper function approach. So let's go ahead with while void print permutations helper. So reason we are introducing this helper function is, you very well know, since it was explained earlier videos, that we need to have one extra parameter to keep track of the position, right? So all the logic that we have to write, we will be writing here, because this is where we are going to fill the positions. And what we will do from the actual function, we will be calling this function, and we will be telling that function that, hey function, you start with 0 as your first position, and after that you use the permutation going ahead, right? So this is what our logic would be. So fill 0th position with all the choices. So when it calls with 0, it says, okay, fill 0th position with all the choices, and it gets all the choices from somewhere, and after that it follows each choice. So that is where our tree, recursion tree, starts building. And then when it runs out of choices, it comes back and says, hey, I'm done with all the permutations, and we have a happy path. Okay, so let's start with here. Now how do we keep track of our choices? And trick that we'll use is, we will not use additional array. This is the trick that I'll be telling you how to do this. So to fill a position, we need to know what are our choices. So if our index is 0, the choices are 0, 1 and 2. If our array is ABC, or here it is numbers, but that's fine, we can take this example. Now if you have to fill the 0th position, our choice is A or B or C. We can go with any choice, right? So what we do is, we first fill our choice. So that means we can go ahead with the choice of A, B or C. Now how do we fill that in 0th position? A is already there. So the way we do that is swap current index with the choice index. So this is what we will do. We will say for int I is equal to, for int x is equal to I, x less than n, x plus plus. This is what we are going to do, right? So first what choice we will fill is, so this x is, since we have 3 choices available, first we are saying let's fill ith index with this x choice, then fill this index with choice b, and when b becomes a choice, a will be swapped. So when b becomes a choice, we know that a and c are the remaining characters. So here the trick that we are using is, we will say in array swap x with I. So swap x with I, what we are saying is we are swapping A with A. So since A has moved backside, we say A is done. Now your remaining choices are B and C. Go ahead and follow the path. And once we come back, we'll swap A of X of I once again. So this step is actually backtracking step, right? And we'll write the swap function. It will become clear. Don't worry if this is not becoming clear to you right now what we are doing. I'll explain it once again. So we go and do swap. So here our array is integer array. So we swap int I index and int j index, and that is a separate function. We'll write p is equal to a of I, and a of I is equal to a of j, and a of j is equal to t. So this function will help us swap. So we first swap, take a choice and mark it as done. And once this choice is done, that means for position I, then what we need to do is we again call this function recursively, and we say currently we have filled something in 0th position. Let's go and fill I plus 1th position. This is what we are doing. As we saw in animation, the recursion tree we were following, we were first fixing the 0th position. So now you can think about it. This will be very clear now to you. ABC when we have, so what we are doing is let's swap A with A. So this is saying that we are taking choice A and we are marking it done, 0th choice, and then we are making a call with go ahead and now fill the second place. So that recursion will go, and once that comes back, we kind of bring A and B back to their normal position. The reason we are bringing back to their normal position is because next in this loop we will be going to C also, and C also needs to go front, A will go back. So that way C will have its both the options available, right? So this is very small code, but make sure that you understand why we are doing what we are doing. So these steps should be very clear. I'm just removing these comments since they are clear now. So let me get rid of all of that, and let me get rid of this. Now two questions come, is when do we print and when do we backtrack, right? So backtracking, as I said, is this step, and after all the choices, like here we are take choices one by one, and once all the choices are over, after for loop is done for any I, then we go back to the end of the function and we return eventually. That's one backtracking. Second is, now when do we print? So we say if I becomes n, so now n is not a valid position in the array, so that means if I has become n, we are almost done, we don't need to do anything. So the permutation is ready. So here we can say print array, because array has a permutation now, and after doing that just return. So this is again a backtrack path, right? So let's write this function also, print array int a int n, and this is void, and the way we print is, let's see in example what does it say. That okay, we should be printing every permutation in a separate line. Oh my god, I missed my code changes. I'll write it once again and we'll resume from there. Okay, so I have written the code once again, and here we were returning. So what we are doing is we wrote a helper function over here, and in this helper function we are first checking if I is n, print array a to n, and I have written the print array function also. So here we are simply writing a loop over the array. We are printing ai and we are printing the new line. Okay, so let me just check the spelling mistakes. If I have done any, copy paste here, copy paste here, and the swap function that we are calling has been written over here. Great. So this is pretty much the code for our uh, print permutations. So now let's quickly validate that our code will give the desired output or not. So we have written it, and let's do a submit. So submit will try to compile our code and test it against various test cases that are there on Mentorpix site. And if all the test cases pass, it will say, okay, your algorithm is accepted. So we see all three test cases are passing, and we are able to generate the permutations. So this was the code. Try thinking about it yourself and try to write this code yourself. Like, don't copy paste the code from the video. Don't try to like copy. Just think. The concept is important. And this permutation has a lot of variations of interview problems that we will be discussing in upcoming videos. So please make sure that you are able to think of the logic, convert your logic into code, and understand the reason behind why we are doing this swap, why we are doing the reverse swap, what is the purpose of each of those, and how this small piece of code, if you see, actually this is nothing but less than 10 lines of code which is helping us generate all the permutations, right? So thanks for watching. So once you have mastered this concept, move on to the 5-6 variations of interview problems that are there on permutations.